all are doing well. Today we are going to start with a very interesting topic. We are going to study a very interesting topic. It is light and how light helps us to see objects around us. Basically, light helps us to see objects with the principle of reflection. So first let us know what light is. Okay, light is a form of energy which helps us to see things around us. Okay. All right. So any entity that helps us for seeing around us the things that are around us, so basically it is light. All right. Now, how do we see objects around us? We see objects around us when light falls on an object and it reflects back to another person's eyes. For example, if you are able to see a table in front of you, how does it happen? Why you are able to see a table in front of you? Because of course, say this is a wall. All right, this is a wall and I have a painting hung on the wall. All right. Now, why will I be able to see the painting as well as the wall? Because say you have a source of light here. Okay, this is a source of light. So from this light, rays will go and strike the painting as well as the wall. All right. So what happens? After striking the wall, the light rays will reflect back. The light rays will reflect back in various directions. All right. The light rays will reflect back in various directions. So some of the light rays will reflect back to the observer's eyes. All right. Some of the light rays will reflect back to the observer's eyes. And what happens? There is inside our eyes there is a screen called retina. All right. So whatever amount of light is reflected from this painting or the wall, it enters our eyes and an image of this object is formed here in the retina. A screen is there in our eyes, inside our eyes, in the eyeball. Okay, it is called retina. Okay, it is like a screen on which the entire object's image will be formed. The painting's image will be formed here. This is how we are able to see an object. All right, the image is formed. Okay, now this is the basic principle of reflection. All right, how can we see objects around us? Simple, by reflection. Whenever light falls on an object, it bounces back to the observer's eye. So reflection, in short, you can say bouncing back of light. Bouncing back of light is called reflection. All right. So bouncing back of light is reflection. Say now, how can we see our image in a mirror? Right? You can ask me, we can see our image in a mirror, but why we cannot see our image on a plain polished table? All right. If a table has a very plain surface, can we see our face very clearly on it? No, we cannot. But the table is very smooth. Okay, it seems very plain and smooth. But why we are able to see our image in a mirror? The difference is that when you are taking the surface of a table, it looks very plain and smooth. But when you magnify the surface of the table and see, you will see that it is rough surface like this. Curvature is there. So when light falls, it does not travel in a particular opposite direction every time. Okay, but in the case of a mirror, say this is a plain mirror. Okay, in the case of a mirror where we can see ourselves, if a light ray falls on it, it reflects back or it bounces back exactly in the opposite direction. Okay, the first ray of light which falls, the ray of light which falls on the mirror is called the incident ray. This is called incident ray. and when the incident ray bounces back, that means reflects back, it is called the reflected ray. Alright, so if the incident ray falls here, exactly in the opposite direction it will reflect. Alright, always represent the rays of light with arrows, otherwise you will not understand. Other people, when they look at the diagram, they will not understand which is the incident ray and which is the reflected ray. So always mark with arrows. Alright, so this is the incident ray and this will be the reflected ray. So in case of a mirror, you will always see that the incident ray and the reflected ray are always in the opposite direction to each other. Clear? This is a plane mirror. This is the back side of the plane mirror. This is the rough surface, back side. Okay? And this is the front part, that is the plane surface of the mirror. Alright? Understood the logic behind mirror? Now, if the same thing we do with a table, alright? Just a second. So we have a table here. On the surface of the table, you won't be able to see your face properly. Why does this happen? Because when you magnify this surface, normally it looks very plain, normal, alright, very smooth. But when you magnify, you will see that it is actually curved. In minuscule level, you will see that it is actually curved. Whereas, if you magnify the surface of the mirror, you will see that it is plain only, plain and smooth. Alright, so since it is actually curved here, alright, since it is actually curved here, so in general it looks very smooth and plain, but it is actually curved. So when the incident light falls on it, the reflection doesn't happen exactly opposite. It can reflect back in different angles. Alright, so this is why you will see that the reflection of the light, the reflected light on a smooth plain table, although the table looks very smooth and plain, the reflection of the light is not exactly opposite to the incident ray. The reflected ray is not exactly opposite to the incident ray. This is why an image of our face or of any object is not formed on a table, on the surface of a table or on the surface of a wall which is very finely painted also. Alright, because of this property. Now, coming to plane mirror again. Coming to plane mirror again. Say this is a plane mirror. This is the incident ray, the ray of light that comes from a source. Say there is a bulb here. Okay, there is a ray of light, a bulb is, or a laser light is here. Okay, a laser is here from which the rays have been shot on the mirror. So this is the incident ray. Alright, so the reflection will happen opposite direction, in the opposite direction, exactly in the opposite direction. Alright, now there is an angle formed between it and there is a imaginary line which we call as normal. This normal divides this angle into two equal parts. Okay, this angle is divided equally. This is the incident ray. Okay, this is the reflected ray. Alright, remember the incident ray has been shown with a downward arrow, that is incoming towards the mirror. The reflected ray is bounced back. Okay, has bounced back. So the angle formed between is exactly divided by an imaginary line which is called the normal. Very important. Alright, so this angle is called angle of incidence. Alright, this angle is called angle of incidence. This angle is called angle of reflection. So since the incident ray and the reflected ray are exactly opposite to each other, that means the normal divides these two angles into equal parts. So what happens? Angle of incidence becomes equal to angle of reflection. Alright, I hope you are clear with this. Now, say if I take the incident ray and I make it more inclined towards the mirror, alright, if I take an incident ray and make it more inclined towards the mirror, this will also become more more inclined, the reflected ray will also become more inclined towards the mirror. What I am trying to say here is that, say for example, I have these two pens and this is a mirror here, alright. So if this is the incident ray, if this is the incident ray on the mirror, if this phone is the mirror, so if this is the incident ray on the mirror, this will be the reflected ray directly opposite, right? If I bend this light incident ray, okay, understand this, if I bend this incident ray, this reflected ray will also bend. The more incident ray will come closer to the mirror, the more reflected ray will also come closer to the mirror, alright. If I bend it like this, reflected ray will also bend like this. If I bend like this, reflected ray also will bend like this. That means the more I bring the incident ray closer to the normal, the more the reflected ray will also come closer to the normal. Alright, take it this way. Say this is the mirror, this is the normal. So the more I bring the incident ray closer to the normal, the reflected ray will also bounce back directly in the opposite direction, becoming closer to the normal. You see the distance between the incident ray and the normal has reduced, and so the distance between the reflected ray and the normal has also reduced. Alright. Okay. Same way, if I take the incident ray farther away from the normal, reflected ray will also be going farther away from the normal. You see, I hope you are clear. Okay, this is a property of the mirror. Now if this is the incident ray, this is the reflected ray. If I change the plane of the incident ray, that means if I put the incident ray this side, the reflected ray will also turn this side. Understood? So the reflected ray totally depends upon the position of the incident ray on the mirror. Clear? Okay. Next, what are the properties of a plane mirror? Till now we have been discussing about plane mirror, remember that. Okay. Properties of plane mirror. So the distance of the object from the mirror is equal to the image formed inside the mirror. Okay, means what I am trying to say is, suppose this is a plane mirror. Okay, you are standing here in front of the plane mirror. Say your distance and the plane mirror's distance is 2 meters. So the object that will be forming inside the mirror, this is the rough surface of the mirror. This is plane mirror, huh? So your image that will be forming inside the mirror will be exactly 2 meters away. That means if you walk 5 steps towards the plane mirror, your image will also walk 5 steps towards the plane mirror. Okay, so the distance of the object from the mirror and the distance of the image from the mirror that is inside are equal, are same. Alright. Next, the image formed in a plane mirror is virtual and erect. What is erect? Erect means if this is the object, the image inside the mirror will be formed in the same way. Same way in the sense, if this is my head to toe, I will see myself in the mirror head to toe only, not toe to head. Okay, that is erect, straight. Alright, so the image formed in a plane mirror is virtual and erect. You understood the meaning of erect? Virtual means an image which is not real. That means you can only have the image in a mirror, but you cannot have the image formed on a screen. Suppose you went to watch a movie. Okay, what do you see? The actor's face. If your right hand is this, the actor's right hand will be the opposite one. That is a type of real image, the image that can be formed on a screen. And one best example is TV screen or cinema screen, where you can see the actors, actresses, whoever is there, your right hand and their right hand will be in the opposite direction. Alright, so this type of images are called real images. Whereas, if you see yourself in a mirror, you raise your right hand, the image, your image in the mirror will raise its left hand. Okay, that is a virtual image. Alright, if it was a real image, you would have seen your backside in the mirror. So a mirror can never form a real image, it will always form a virtual and an erect image. Erect image, that is the size of the object and the size of the image, and the way they are facing each other is exactly same. Alright, so virtual means non-real image, that means your right hand is the image's left hand in the mirror. Okay, next. The size of the object and size of the image are same. Clear? Whatever is my height, say I am 5.8, 5.9, whatever, the image that will be formed inside the mirror will also be 5.8 or 5.9. My height is equal to the image's height. In short, finish. Because it is a plane mirror, straight, plain, smooth surface, straight mirror. Alright, so the object height and the image height will be same. Alright, the image formed is laterally inverted. Laterally inverted. See, one word is, a word is there, inverted. Inverted means if this is the object, alright, if this is the object, head to toe, this will be the image, toe to head, that is called inverted. But laterally inverted means this is the object, head to toe, this will be the image, head to toe, but the object's right hand side will be the image's left hand side. That kind of inversion is called laterally inverted. Okay, it is not becoming upside down, it is upside up only, but the position of left hand side of the object is the right hand side in the image in a plane mirror. Okay, that is laterally inverted. Alright, so I hope you are clear about the properties of plane mirror. Alright, so what have we learned? We have learned what light is, okay, then how light helps us to see objects around us. Light helps us to see objects around us with the help of reflection. That means when light bounces back from an object and enters our eyes, the image is formed in our eyes. Alright, now, so laws of reflection of plane mirror. Understand one thing, if this is the plane mirror, again I am telling you, this is the incident ray, just in the opposite direction there will be reflected ray. So this is incident ray, this is reflected ray, and this is the normal, right? This is the normal. what can you see? You can see that the incident ray, the reflected ray and the normal all are lying on the surface of the plane mirror, that is on the same plane, none of them is crossing the plane and going on the other part. So the incident ray, the reflected ray and the normal all lie in the same plane, that means on the same surface all of them will lie. Okay, next, the angle of incidence is always equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. These are the two laws of reflection in a plane mirror. Now, one additional property that I want to tell you about plane mirror is that if these two are equal, then the angle between the mirror and the incident ray is always equal to the angle between the mirror and the reflected ray also. The more you keep on increasing the incident ray, the distance of the incident ray, if it increases from the normal, this angle will also keep on reducing and it will become equal to this angle. So the angle between the mirror and the incident ray is always equal to the angle between the mirror and the reflected ray. That means the distance of the incident ray and the distance of the reflected ray is always equal at equal distances from the mirror. Types of mirrors, we have learned about plane mirrors. Okay, just now we have learned about plane mirrors. Just a second, we have learned about plane mirrors. Now we will learn about spherical mirrors. Okay, spherical mirrors. Spherical mirrors means, of course, from the term it is clear that spherical mirrors are circular, or you can say spherical in shape. Spherical mirrors are of two types, concave and convex. Alright, so first we will do about concave mirror. Alright, so what is a concave mirror? You see, suppose you have a sphere. Okay, you have a sphere, outside is rough surface, but the inner part is reflecting surface, shiny surface like a mirror. So what you do, you cut this part and take it out. Okay, so what happens is, yes, if you cut this part and take it out, you will have a reflecting surface that is inside, inward reflecting surface. Okay, now this kind of a mirror which has its reflecting surface curved inside is called a concave mirror. Alright, so such a mirror which is curved inside is called a concave mirror. Alright, for your for you to remember it easily, imagine it this way. Cave means a cave always is curved inside, right? Cave. So when it is mentioned cave, that means you should understand that the reflecting surface is inside. Such a mirror is called a concave mirror. Alright, now concave mirror is also known as converging mirror. Converging mirror. Why? I'll tell you now. See, whenever a light ray falls on it, say these are parallel light rays falling on it. Okay, the light rays are bent inwards. The light rays are bent inwards. Okay, so that is why this is the incident ray, these are the reflected ray. All right. So why it is a converging mirror? Because all the light, all the rays of light that are reflected, that are incident on the mirror, are reflected towards a particular point, are reflected or converged, they are brought together to a particular point. That is why concave mirror is also called converging mirror. Alright. Now, next is convex mirror. Alright, we'll draw it here. Next we have is convex mirror. Okay, so the opposite of concave mirror is convex mirror. Say we have another spherical ball here, that means this spherical ball is, it has a rough surface inside, but the outside is a reflecting surface. Outside is a reflecting surface. Alright, let me draw it here. One second. So see, say the inside is a rough surface, but the outside is a reflecting surface. Alright, so you cut this part here, and what you do, cut this part of the mirror, what do you get? You get a part of the mirror that is bulging outwards, like this, bulging outwards. So this is the rough surface, this is the smooth plain surface where your reflection will come. Okay, so such kind of a mirror is called convex mirror. Now convex mirror is also called diverging mirror. Why, you see? Okay, I'll tell you. Because when you shine incident light on a convex mirror, you will see that the reflected rays are thrown away. Alright, the reflected light rays are thrown away, and it seems that all these reflected rays are coming from a point that is behind the mirror. Okay, it seems that all these reflected rays are coming from a point that is behind the mirror. Okay, from a point that is behind the mirror. In actuality, originally, it is not like this. Alright, it is not like this. It is, the reflected rays are actually bounced back from the surface of the mirror only, but it seems like that these rays are coming from somewhere behind the mirror, at a point situated behind the mirror. Alright, so that is why it is called diverging mirror. Why? It spreads the light. Concave mirror, it accumulates the light, the rays of the light at a single point. Alright, so what we can see here is that in the case of a plane mirror, we were not able to form the image on a screen. The image was formed inside the mirror only. But in the case of a concave mirror, you can see that the light rays are reflected forward in front of the mirror at a single point. That means if you put a screen here, you can get an image depending on where you have placed the object. We will study about all this, means in detail about concave mirror, what kind of image it forms. Okay, both the mirrors, concave mirror and convex mirror. But in short, you can understand that if you place a screen here, the image can be formed because all the light rays are reflected back in front of the mirror. Inside the mirror, no case, nothing is happening. Alright, so it is possible to get an image on the screen in case of a concave mirror. That means a concave mirror can form a real image. Okay, plane mirror cannot form a real image because we cannot get the image on the screen. But here, if you place a screen, you can get the image. Okay, so real image is possible in case of a concave mirror. Whereas in case of convex mirror, again, it seems that the reflected rays are coming from a point, but actually it is not coming anywhere from behind the mirror. Okay, so real image will not be possible in case of convex mirror as well. All right. Okay.